Good morning everyone, my name is Ramesh Bharadwaj and today we are going to look at the third experiment of Signals and Systems Laboratory, that is analyzing the sound signals, but namely fan, speech and train. So let's get started. Um, so let us look at the coding part of the functions. Now we were told now I have collected the 1 hour data of train, fan and speech, and what we will be doing is basically we will be taking the variance and kurtosis skewness values for the first 30 minutes and we will be comparing and analyzing for the second 30 minutes of the same data. So as you can see, I have taken the train sound data for first 30 minutes. For first 30 minutes is basically 1 to 1800 seconds. So the samples one will be storing the data for 1 to 1800 seconds, and next I have created once matrices for train and train vary, train skew and train curve. What they will be doing will be discussed later, and train here will be storing the normalized data of this train. So I have already created the audio normalization function in the MATLAB. So by using that function we will be correcting the normalized data of the train sound. So next I have created the for loop for I is equal to 1 to 1800 seconds. Why 1 to 1800 means we will be looking at each second and noting the values for each second, then noting the data values for each second. As you can see here, I have assigned train I is equal to n train of for 1 plus I minus 1 to 16,000 is to 1 I into 16,000. So this is basically the n train values will be, so what this statement does is it will be taking 16,000 rows of the first 16,000 rows of n train and it will assign them to train. And now this for I is equal to 1, and for I equal to 2 it will be taking the next 16,000 rows of n train and it will be assigning to train. So in this way we will be assigning the normalized data to the train I, and using now once the train I has been defined, the train vary of I will be having the variance values of all the data of the train I. As you can see here, I have given where of train I, where is a predefined variance function in MATLAB which will be collecting the variance data. So the where of train I will be collecting the variance data and it will be assigning to train vary of I. Similarly for train skew and train curve, the skewness and kurtosis, which are the predefined functions in MATLAB, will be collecting the train skewness and kurtosis data and will be assigning to train skew and train curve. Now once I have collected all the data, I will be looking for the maximum and minimum in maximum and minimum in the statistical parameters of the data. Now the train var of max will be storing the maximum in the train vary data, and train var of min will be storing the minimum of train vary data, and the cut max and cut means skew max and skew min will be storing the max and minimum of their respective parameters. So in this way we will be storing the first 30 minutes data maximum and minimum in this way. So once I have assigned all the values, I have created the table to for all the 1800 seconds and I have created an Excel sheet. So this right table creates it, and similarly just like we did for the train, similarly we will be doing for the fan for the first 13 minutes. I have created one matrices, and again I have assign the normalized data for first 16,000 rows to second 16,000 rows. Again it will be keep on assigning for the fan, and vary and skew again will be containing the variance, skewness and kurtosis values respectively of fan, and again I have created the maximum minimum values of variance, kurtosis and skewness. So in this way all the data will be stored for fan also. And exactly in the as we have discussed above, for speech also we will be defining variance, skewness and kurtosis and assigning the maximum minimum to the respective variables. And now once we are done with the first 30 minutes, let us come to the second 30 minutes. Now second 30 minutes we can obtain second data for second 30 minutes by using from 1800 to 3600 seconds. So this will give us the second 30 minutes data. So just like the first part, we will be creating train 1, train vary 1. Again we will be assigning them to once matrices, and also we will be using these variables to make computer recognize which signal is which. So we will come to this part later. Now I have, as you can see, I have assigned one matrices all here, and again the audio normalization comes into picture. Again the train one does the same. Everything is same in the first part. Now once I have collected the variance, skewness and kurtosis data of train for the second 30 minutes part, I will be comparing it with the first 30 minutes part. So the first 30 minutes part, the second 30 minutes part variance must lie between, if it lies between the maximum and minimum of variance values of the first 30 minutes, then TV1 will be added by 1. And if the train variance data of the second 30 minutes part is, if it is between maximum minimum for fan variance of first 30 minutes, then TV2 will be added by 1. So if again similarly if it was speech, then TV3 will be added by 1. Now this was for variance. Similarly, if we take skewness into consideration, if the skewness data of the second train part, if it lies between first train part skewness maximum minimum, then TS1 will be added by 1. If it is for fan, then it will be added by 1 for TS2, and for T, if it lies between speech maximum minimum, and then TS3 will be added by 1. So this was for skewness. Again similarly for kurtosis, as you can see here, the curve 1 lies between curt max and curt min, and fan curt max, curt min, etc. So again TK1 will be added by 1, TK2 will be added by 1, TK3 will be added by 1. So this was for train second 30 minutes data. Now let us come to fan 30 minutes, second 30 minutes part. Again we can see the fan from 1800 to 3600. Now again using audio read, we will be reading all the samples from 1800 to 3600 seconds. Again I have created the matrices here. Again I have defined the variables to 0, and again I have normalized the data or fan equal to audio normalization. Again I have stored the variance, skewness, kurtosis of the second 30-minute data in vari1, skew1, cur1. Now again we need to compare just like we did for the second 30 minutes part of the train. So the fan vary 1 will, if the fan vary 1 lies between train max and train min, then FV1 will be added by 1. And that if fan vary 1 lies between fan vary max and fan vary min of first 30 minutes data, then FV2 will be added by 1. Now if a speech where if it lies between speech where max and speech where min, then FE3 will be added by 1. So this was for fan varying variance of second part. Similarly for skewness and cur1, skew1 and cur1, the same method will be repeated. So that's it. Now again for similarly for speech also, we will be creating the speech where 1 and where 2 for second 30 minutes data, and it will be comparing it with the first 30 minutes data and adding 1 if it is between a certain interval. Now that's the end of it. Now we will be creating one matrices of 3 by 3 because confusion matrices basically. So what I do is I have assigned variance of ACC and skew ACC and cut A account into ones of 3 3. Now once the TV1, TV2, TV3, TS1, TS2, TS3, all the the 27 variables will be assigned in the above for loops or if loops. I will be assigning the each and every element in this matrices with the respective value. Variance of account 1 1. This is for variance data. So variance data will be equal to TV1, TV2, TV3, and the second row will be containing the fan data, and the third row will be containing the speech data. Similarly for skew skew account, so TS1 again FS1 SS1, again TS2 FS2 SS2, as you can see, again TS3 SS3. So that is for skew and kurtosis. Now once I have already created these matrices, why I have created these matrices was basically we can assign them directly into the table data of GUI. So you can see here, this is my design view of GUI. Come on, man. So as you can see here, this is the design view of my GUI. I have created this radio button box, and I have already created 3 UI axes along with a table. So creating that matrix will help directly assigning the vectors into this each cell of the table. So you can see here, this is the GUI code, table data, and once I have created if we select the variance button, then the table data will be having the variance data of all the 3 signals, and all the histograms will be plotted in the axes for the train, fan and speech. Similarly for skewness and kurtosis. This was the coding part. Now I have already executed this code and I have obtained the GUI app. Now unfortunately because my processor is very slow, so I was just able to take a screenshot of kurtosis data and I was unable to obtain the skewness and variance data. But I have already reported the values in a report. So as you can see, this is the screenshot I have taken for train, speech and fan, and the data table confusion matrix is respectively here. So this was the only uh, objection that I have faced here. So that's it. I hope you can excuse me, and thank you for listening to my video. Thank you.